Right, so the next question we're going to look at is page 322, question 13. Now, I think we actually have done this question before, but I'll do it again anyway. Two vertical poles, so pole A and pole B, each of height h, are standing on opposite sides of a level road. They are 25 meters apart. The point P on the road directly between the two poles is the distance x from pole A. The angle of elevation from P to the top of the pole is 60 degrees. Write h in terms of x. So h is the height of the pole. Okay, so I can just use what I know here. This is a right angle triangle because then things are built at right angles. So h, O, this is the angle I know, so this is O and this is A. So if I want to write h in terms of x, I have a formula there. Okay, I can say this is the opposite, this is hypotenuse. So looking at my SOHCAHTOA, opposite and hypotenuse is sine. Okay. Sorry, I actually don't know the value of the hypotenuse. Okay, so it's actually the adjacent I'm going to use because the question said adjacent, sorry. The question said in terms of x, so I actually want to use x. So I'm actually not using sine, I'm using tan. Okay, so I'm going to say tan of 60 degrees is equal to my opposite, which is h, because I want h and x, that's why I'm using those, over the adjacent, which is x. So the question said write h in terms of x. So I want h on its own. So how do you get rid of a divide by x? You multiply by x. Okay, so that's going to be x tan 60 degrees is equal to h. Now you can put tan 60 degrees into your calculator and that will give you the square root of 3. So I can say my answer is the square root of 3x is equal to h. Now, it's only the x isn't over the square root. Okay, because tan 60 is the square root of 3 and then you've got your x. So I've written h in terms of x. So the height is square root of 3x. Okay. From P, then it's saying the angle of elevation to the top of the pole is 30 degrees. Find h, the height of the two poles. Now, what I'm going to do first of all is I know that all of this is 24. Okay, I'm looking for the height of the two poles. Okay, now I'm going to use here this time. I'm going to use this side. So I'm going to look at this and I know the length, all of this is 24. So I know the length here is 24 minus x. So the length from here to here. Okay. So if I look at this triangle, right angle triangle here. Okay. I don't know the hypotenuse, but I have a value of the opposite and the adjacent in terms of x. They both have x in them. Okay, but I can use that. So I'm going to say the formula that I'm going to use is tan because I have opposite and adjacent. So I'm going to say tan 30 degrees is equal to the opposite, which is root 3x, all over the adjacent, which is 24 minus x. Okay, now if I put tan 30 degrees into my calculator, it will give me 1 over root 3. Okay, it'll also be in your log tables. Is equal to root 3x all over 24 minus x. Now, when you have an equal sign in between two fractions, you just can cross multiply. So 1 by 24 minus x is 24 minus x. Root 3 by root 3 is root 9, which is 3. Okay, x. Now, I want to find out what x is because I want to find the height of the pole and I know the height in terms of x, but I want to find what x is. So I'm going to say 24 is equal to 3x plus x. So bring the minus x over to put the x's together. So that gives me a value then, 24 is equal to 4x, or 4x is equal to 24. So that means x is equal to 6. So if x is equal to 6 and h is equal to the square root of 3x, then I can say h is equal to the square root of 3 multiplied by 6, or I can say it 6 root 3. And the measure of the units are meters. You can, if you want, because it doesn't ask you, you can convert it to decimal if you want. But I'd always write it that way first. Okay? The height of the pole is 20.39 meters. Now that question is quite a tricky question now, to be fair. Okay. Page 340 then is our next question. Okay. So question 12, it says the graph below shows the relationships between distances travelled and fuel consumption for John's car. The segments line 1 and line 2 represent the fuel consumption at steady speeds of 60 kilometers and 100 kilometers respectively. Okay. So the first thing we're going to do, it's asking us to find the slopes. Okay. Now, we've only one coordinate on each line. Well, we have two technically, actually. We have the origin as well. So you can use your slope formula. Okay. And you can go x1, y1 is 0, x2, y2 are these values, and the same with the other line. Or you can use your rise over run. If you use your rise over run, you can just calculate exactly what the values are. So this is our x value. So the distance from here to here is 25, and this is our y value, 275. Okay, so we could say the rise over the run is 275 over 25, which is 11. So that's for line 1. And for line 2, well, we know that this distance here is 40, and this distance here, okay, is 340. So you can say the rise over run is 340 over 40, which is 8.5, or 17 over 2. The next thing it says, what do these slopes tell you about the fuel consumption? Okay, so the higher slope for line 1, we could say indicates that you get a more kilometer per liter at the lower speed, or basically you can say more fuel is used at the higher speed. Okay, so the higher slope indicates that more fuel is used when the car is going at the speed of 100 kilometers per hour. Okay, so the higher slope for line 1 indicates more fuel consumption at the higher speed. Now, the next thing it says, fuel costs 149.9 cents per litre. John drives a distance of 2 kilometers at a steady speed. How much cheaper is the journey at 60 kilometers per hour than at 100 kilometers per hour? Okay, so if we were to write the equations of these lines, okay, we know, excuse me, that we have two formulas. One of the formulas is y equals mx plus c. Okay, so if I use this formula for line 1, okay, y equals, the slope is 11x. Where does the line cross the y-axis? At 0. So the equation of the line is y equals 11x plus 0, or just y equals 11x. Line 2, y equals m, we know the slope is 8.5, mx plus c. But again, It crosses the y-axis at 0, so there is no constant. Okay, so those are the two equations of the line, and it says fuel costs 149.9 cents per litre. So X stands for our litres. Okay, so I'm going to sub in here and say Y. I'm going to say Y is our distance, isn't it? Okay, so John drives a distance of 200 kilometers. Okay, so I want to figure out how much liters of fuel he will consume, isn't it? Yeah, so I'm going to say y equals 11x, or I can say 11x is equal to y, just turn it upside down, and I'm going to say 11x is equal to 200, so x is equal to 18.81, so that's our number of litres. We know it's 149.9 cents per litre, so we multiply that, and that gives me a value when you convert it to euros as 27.25. Okay, same here then, so I'm going to say 8.5x is equal to 200, and I'm going to find out how many litres it will use. So 200 divided by 8.5 will give me 25.35 litres. Multiply that by the cost per litre, and when I convert it to euro, it gives me 35.27. Now, the question says, how much cheaper is the journey? So you actually have to find the difference. Okay, so subtract one from the other, and you get a difference of €8.02. Right, that again, some of that was quite tricky. Page 341 then. Now, there was a lot to this question. So, this is a map which shows part of a town containing a park and some streets. Distances are measured in kilometres, horizontally and vertically from the town hall, and shown in coordinate form. Okay, so here we're seeing the town hall, I'd say, is at 0, 0. So we're asked, how long is the path from B to C? So there's a path here, and I want to find how long it is. So these are coordinates, so we're thinking coordinate geometry. When you think how long, you should think distance and write down your distance formula, which is square root of x2 minus x1 squared plus y2 minus y1 squared. Please be familiar with these, they're in your log tables. So call this x1, y1, x2, y2, and sub it in. So x2 is 10 minus x1 is 3 squared, y2 is 9 minus y1 is 10 squared. 10 minus 3 is 7 squared, 9 minus 10 is minus 1 squared. Square root of 49 plus 1 gives me the square root of 50. If you want to convert it to a decimal, you can. 7.0710678812, and it actually says to convert it correct to 3 significant figures. So if it says 3 significant figures, you're looking at the first 3. Remember the difference between 3 decimal places and 3 significant figures. Decimal places are the numbers after the decimal point. So that's the first significant figure, second, third. So you look at the fourth. If it's 5 or greater, this is increased by 1, but it's less than 5, so my answer is 7.07, and we're talking about the distance, so it's 7.07 kilometers. Right, the next part of the question says E is the center of Round Park. Okay. How much shorter is it to walk directly from B to C rather than, so directly from B to C, rather than take the path to E and then on to C? Okay. So take the path to E and then on to C. Okay. So if you were going from here to here and here to here. So you have to use your distance formula to find the distance from here to here. Then you use your distance formula to find the distance from here to here and compare the two distances. Okay? So to find the distance from B to E, B is 3 and 10, E is 6 and 6. Call it x1, y1, x2, y2. Write your distance formula, x2 minus x1 squared plus y2 minus y1 squared. Sub into your formula. So 6 minus 3 squared plus 6 minus 10 squared, square root 3 squared plus minus 4 squared. We know any negative number to an even power is always positive. So that's the square root of 25, which is 5 kilometers. So it's 5 kilometers from B to E. Then from E to C, we use our distance formula again. And that goes 10 minus 6 squared plus 9 minus 6 squared. You're subbing in the values. So that gives me 4 squared plus 3 squared, 16 plus 9, square root of 25, which is 5 as well. So that means if you were looking at that as a triangle, it would be an isosceles triangle, because that's the distance from here to here is 5 kilometers. The distance from here to here is 5 kilometers. And we found in part A, the distance from B to C is 7.07 kilometers. So how much shorter is it from going from B to C than from going B to E and E to C? So just subtract the difference. So it's going to be 10 minus 7.07, which gives me 2.93 kilometers. Now, although you have the hard work done in these two pieces, you will not get full marks. So you will lose, if that was worth 10 marks, you'd lose 3 marks for not doing that part. So always go back and see if you answered what you were asked. And it said, give your answer to the nearest kilometer. So you actually have to write that to the nearest kilometer. So that is 3 kilometers. Okay. The next part of the question says the point A and B are on tangent street. Find the equation of tangent street. So the points A and B are on tangent street. So a tangent, as we know, is not relevant necessarily to this question, but they are a line touching a circle in one place. So this is tangent street here. To find the equation of a line, we know that you need a point on the line and the slope. Okay, so the first thing we'll do, we'll write down our points A, B. So, well, points are given here. So call that x1, y1, x2, y2. And we want to find our slope. So it's kind of tricky using rise over run here. So the easiest thing is to use your slope formula. Always write down your slope formula when you see anything in relation to equation of a line. So I'm going to sub into that, and that is 10 minus 8.5 all over 3 minus 1, which gives me 1.5 over 2, or 3 over 4. Okay, so that's the slope of the line, and it's a positive slope, and the line is going up from left to right, so we know that's correct. Okay, and the next thing is, in order to find the equation of a line, you write down your formula. And the two things you need are a point on the line and the slope. So we're going to use the 3 and 10 as our point on the line. So I'm going to call that x1, y1. And my slope is 3 over 4. So subbing that in, y minus y1 equals m, which is 3 over 4, by x minus x1. Now, we've already done this. To get rid of, we don't want a fraction, so we want to get rid of the divide by 4 here. So you multiply by 4, you multiply the left hand side by 4. Then multiply out the brackets. That's 4y minus 40 equals 3x minus 9. Bring everything to the left-hand side. So it's minus 3x, because when it crosses the equal to sign, it's minus 3x plus 4y minus 40 plus 9 equals 0. Simplify. Minus 40 plus 9 is plus 31. Now let's see 1 second here. Oh yeah, so that's plus, sorry, that's minus 31. Okay. And then what we're going to do, we don't ever want a minus in front of the x for the equation of a line. So I'm going to multiply across by minus 1. And that gives me 3x minus 4y plus 31 is equal to 0. So that is the equation of tangent street. Okay, so 3x minus 4y plus 31. The next thing we have, so, is perpendicular avenue. So perpendicular avenue is perpendicular to tangent street. Okay, and it says, and passes through the point 17 and 8. Find its equation. So again, to find the equation of a line, you need a point and the slope. We know the point on the line is 17 and 8. We aren't given its equation or its slope, but we're told it's perpendicular to tangent street. So if the slope of tangent street is 3 over 4, then the slope of perpendicular avenue is opposite to that. So it's minus 4 over 3. So now, just to find the equation of a line, you always write down your equation of your line formula and sub in x1, y1 and m. So y minus y1 is equal to m by x minus x1. To get rid of a divide by 3, then you multiply across by, or multiply, sorry, the left hand side by 3. Well, effectively you are multiplying across by 3, which cancels this 3 here. 3 by y minus 8 is equal to minus 4 by x plus x minus 8. Okay, so it's 3y minus 24 is equal to minus 4x plus 32. Okay, you bring everything to the left hand side, so the x comes to the left hand side, so then it becomes a plus. 3y is already on the left hand side, and the 32 comes over and becomes a minus 32. Okay, now looking here, yeah, so I've made an error here. Yeah, apologies. This should have been 17 that I put in here. Okay, so then that would have been a minus 68. Yeah, so then that's 4x plus 3y minus 92 is equal to 0. Okay, right, so now we have the equation of perpendicular avenue. Okay, so this is the equation of tangent street and the equation of perpendicular avenue. Okay, now the question then, the next question says, the museum is located at the intersection of tangent street and perpendicular avenue. Now straight away when you hear the word intersection, you should be thinking simultaneous equation. The question says, find the coordinates of the museum. So we want to find where they meet, so the x and y value where they meet, so we're going to do a simultaneous equation. So the equation of one of the lines is this, and this is the equation of the other line. So again, we want to cancel the x's or the y's. The easiest one to cancel is the y's, because one is already a minus and one is already a plus. So if I multiply this line by 3, it will give me and minus 12y. And if I multiply this line by 3, it'll give me a plus 12y. But again, you have to multiply the entire lines across. So multiplying the top line by 3 will give me 9x minus 12y equals minus 93. And multiplying the second line by 4 will give me 16x plus 12y equals 368. The whole reason I did that is that they will cancel. 9 and 16x is 25x minus 93 plus 368 is 275. And dividing by 25, x is 11. So the x-coordinate where tangent street and perpendicular avenue meet is 11. You then have to find the y-coordinate by taking one of the equations, I'll take this one here, and subbing in your x-coordinate. So solving for y, that's 44 plus 3y is equal to 92. 3y is equal to 92 minus 44. 3y is equal to 48. Y is equal to 16. So the coordinates where tangent street and perpendicular avenue meet are at 11 and 16. Okay, so that there is 11 and 16. Okay, the last question then is, John is at the town hall, okay, and wants to get to the museum. Give one possible route he might take and calculate the distance. Okay, so he wants to get to the museum. Okay, so let's see. He could go east for 1 kilometer. Okay, so we could go from here to here for 1 kilometer. How do we know this is 1 kilometer? Because the town hall is at 0, 0. And we know the x value here is 1. So that distance must be 1 kilometer. He then could go up for 8.5 kilometers because we know the distance from here to here is 8.5 because this is 0, 0 and that's y value here is 8.5. Okay, and then from A to the museum, so from here to here. Now we don't know exactly what that is, so we have to use our distance formula. Okay, so we know that this is 1, this is 8.5. We use our distance formula, sub it in to find the distance from there to there. Okay, so I'll just write that first of all. East for 1 kilometer. To straight road. Then north to A, which is 8.5 kilometers, or 1 kilometer. And then from A to the museum, that straight stretch, and we know that's from 1 and 8.5 to 11 and 16. So x1, y1, x2, y2, sub in, square root, x2 minus x1 squared plus y2 minus y1 squared. You can see I'm practicing what I preach. I always am writing the formulas. So it's 11 minus 1 squared plus y2, which is 16, minus y1 squared. So that's 10 squared plus 7.5 squared, isn't it? Yeah, and that's okay. So we know 10 squared is 100, and we know 7.5 squared is 56.25. So that is 156.25, and the square root of 156.25 gives me 12.5 kilometers. So that's the last stretch of the journey. So it says give one possible route and calculate the total distance. So the initial 1 kilometer, then the 8.5 kilometers, and then your 12.5 kilometers gives you a total of 22 kilometers.